Hi, so in this video, we're going to talk about the proper way to sort user-defined types using different keys. So far in all of the sorting algorithm that we do when we want to test them, we always use input of integers. Now we know we can sort by other built-in types, such as string and float and etc. We also know that we can sort user-defined types. If we override the dunder LT method and the dunder equal method of that type, right? And also once we define these two methods, it's we really can derive the rest of the comparison operators, and we can either write those explicitly, or we can optionally just decorate the type with the total ordering decorator, which would generate those comparisons operators automatically for us. So that's all good. That's what we knew from before. Now, what if there are multiple attributes in a user-defined type, and sometimes we want to sort by one attribute, and other times we want to sort by different attributes. So, for example, in our iTunes data, which is an extreme simplification of what an actual iTunes might contain, it has three attributes: the artist, the title, and the runtime. Right. So probably most usefully, we might want to sort by runtime, but there are use cases that we want to sort by title or by the artist, etc. So how do we achieve that? Well, as it was implemented in the iTunes code, the way it was done was to have a class attribute that determines what of the three attributes to sort by, and then in the dunder LT method, we look at that class attribute, and then we'll just compare the appropriate attribute. So in terms of the actual code, this is how it's done. So in the iTunes entry, there's a sort enum. We can sort by title, sort by artist, and sort by time. And then if you look at the dunder LT method, if the sort by there is also the class attribute, which is sort by. So by default, is sort by time, right? And in the dunder LT method, if sort by is title, well, then we compare title. If sort by is artist, we compare artist, and so on and so forth. And in order then to say sort a list of iTunes, what we have to do is before we call, let's say, quick sort on the list, we have to set the class attribute sort by to, in this case, sort.time, and then we go ahead and sort it. So that seems to work, seems pretty straightforward. However, there are quite a few problems with this approach. And I list some of the problems here. The first problem is anytime there is a new attribute that to sort by, then what we have to do is to add an additional entry into the sort enum, and then we also have to modify the dunder LT to look at the new value and sort and compare the new attribute. Now, if you look at this, it's fine. Now it has only three attributes, but if there are 10, 20, 50, 100 attributes that we can sort by, then this thing gets really long, and the code is just kind of boilerplate, quite boring code, right? So it's bad for maintenance. Now, the second problem is that if you look at how it's being used, this is we set a class attribute to kind of affect or to modify the behavior of a function call at a later time. So that is actually very similar to using global variables to pass in information to a function to change its behavior. It's not quite global, but it's global at a class level. And in my book, that is equally bad. And then the third problem, again, it's kind of has to do with the way these are used. If you just look at these two lines of code without tracing through how this class attribute affects the behavior of iTunes entry, then it's really unclear that the quicksort can actually be affected by this line here. And the reason with that is it's just things are very implicit, right? It's not very clear what these two lines have to do with each other unless you look inside the code of iTunes entries. So, and implicit is bad because, well, I hope you know why it's bad, but if you need any convincing, you can look at PEP 20, which is a Xena Python, and one of the thing it says is explicit is much better than implicit. So, so keep that in mind as you write more code on your own. And then lastly, having a single attribute, but to control the sorting order, it won't. But if we have, let's say concurrent sorting by different attributes, then having a single class attribute really doesn't allow that, because if we're doing two sorting or multiple sortings at the same time, what the value of this class attribute, what should we set it to, right? If it was sorting by different attributes, we cannot. So these are just some of the problem with this approach. So what is a better approach to sort a user-defined type by different attributes? Well, we can tell the sort function, such as quicksort, which attribute to use as the sort key if we give it a key function that will return the sort key. And then the sort function would apply that key function on each of the elements so that it gets the key for comparison. Okay, and so this actually requires a very simple modification to the sort function, and it would avoid all the problems that we just talked about with the previous approach. And let's see how this is actually done with quicksort. So I've already typed it up. This is the quicksort, but this is the new parameter that quicksort is going to take. So this is a key function. Okay, and remember, it's a function, so that when in the partition, when we're trying to figure out if two elements are in the right partition, instead of just comparing iterable left to the pivot, we apply the key function to both of the elements. So the key function would give us the thing, the key to compare. And then same thing when we're comparing iterable right to the pivot, we apply the key function before we actually compare them. Now, what the key function would do, and let's actually look at what the default should do. Right, the default should just the default should do what it did before, which is just to compare the iterable left with the pivot. So that's what this lambda function is doing, right? Given the iterable left as the element, we just return the element itself. So by default, it would just compare the elements themselves. And obviously, you can see that we can customize the lambda function, well, actually the key function, to return a different attribute for comparison. And then the last change we have to do in the quicksort function is, when we do the recursion, we have to remember to pass the key function. So how do we use the key function to sort by runtime? Well, we call quicksort as before, pass it the list of iTunes to be sorted, and for the key function, we specify lambda. This lambda takes an iTunes, which is an element in the iTunes list, and it returns the runtime from that iTunes. And that is the key that we use for comparison, and that is the key that the quicksort will sort this list by. So that's it. It's pretty simple, pretty straightforward, and it's very obvious or explicit of what the quicksort is sorting by. And we can run it just to show that it works now. So after it's sorted by runtime. This is the shortest runtime, and then at the end of this list is the longest runtimes. So, and this approach, it if you think through all the problems we listed previously, it actually addresses each and every single one of them. So now it's your turn. Given this code, try to sort the iTunes by artist and then by title using the key function approach. Well, I hope that you've done the exercise, and I hope that you find this approach to be more preferable than the previous approach. And as a matter of fact, I want to point out that this is how Python's built-in function sorted works, that it takes a key function as a parameter so that it can sort a user-defined type by an arbitrary attribute. And if you actually look at the documentation here, it describes some of the previous approach that it took, and that kind of shows you the perspective of, they finally decided on this key function approach, which I think is a good approach because, as I said, it's pretty clear, pretty explicit, and pretty straightforward.